There is also an auxiliary acceleration pump that assists the acceleration circuit when the engine is cold. When the engine coolant at a low temperature and the VALVE is open, the pressure from the intake manifold causes the diaphragm of the power assist pump to activate and fill the pump with fuel. If sudden acceleration is attempted at this point, since the pressure in the intake manifold falls, the diaphragm spring causes the fuel in the pump to be sprayed out of the nozzle. In this way, the pump makes up for the lack of power in the main speed pump. This brings us to the choke system. Without a choke, it would be difficult to start the engine in cold weather. The choke valve is provided above the nozzle to decrease the amount of intake air during starting. In this way, the choke helps start the engine and improves drivability. At present, as is shown here, the most common type is the automatic choke system. We will also introduce the electric automatic choke, which is currently in use in most vehicles. The automatic choke is controlled by the contraction and expansion of a bimetal element. When the temperature falls below a set level, depressing and releasing the accelerator pedal will cause the choke to be completely closed by the contraction of the bimetal element. After the engine is started, current will flow through the electronic coil. This will generate heat, which will cause the bimetal element to expand and open the choke either slightly or all the way. Here we have the fast idle mechanism, which raises the engine idle speed when the temperature is cold in order to maintain proper engine operation. When starting the engine in cold weather, depressing the accelerator pedal once and then releasing it will cause the fast idle cam, which is connected to the choke valve by a rod, to open the throttle valve slightly. In this way, a slightly higher engine idle speed is achieved. After the engine is warmed up, it will continue to run at a fast idle, even if the choke valve opens, until the accelerator pedal is depressed again. When this happens, the cam follower rides up over the cam and the fast idle is released. This causes the throttle valve to return to the normal idle position and the engine speed to drop. Let's move on now to the unloader mechanism. The unloader prevents the air-fuel mixture from becoming too rich if the engine is started and runs cold without sufficient time given for warming it up. When the accelerator pedal is fully depressed, the throttle shaft arm moves the fast idle cam to force open the choke valve slightly. This allows more air to enter to prevent the mixture from becoming too rich. Let's look at the choke breaker. During cold starts, the choke valve may remain closed, providing an overly rich mixture, which could lead to engine stalling. The choke breaker causes the choke valve to open slightly in this situation to prevent the engine from stalling. When the engine is started, the low intake manifold pressure causes diaphragm A to slightly open the choke valve. After the engine warms up and the coolant temperature rises to normal operating temperature, the VALVE opens, and the vacuum from the intake manifold causes the choke opener diaphragm B to open. After this, the choke valve is operated by the auto choke mechanism.